Hi guys, so the complex number system is all about the imaginary numbers. I always make a joke in class. It's kind of like having your real friends and your imaginary friends. Yeah, we've been working with real numbers up to now, but in the complex number system, we're going to be talking about imaginary numbers. So just a few little definitions. First thing, I want you to notice the difference between where the negative signs are located, whether it would be outside a square root or whether it would be under a square root. If you have a negative number underneath the square root, that means you're going to have an imaginary number. So the imaginary unit I, that's your imaginary number, it is the letter I. It's equal to the square root of -1. Okay, so that's just one of those things you need to remember from now on. I is the square root of -1. That's very, very, very important. I'm going to leave this up here. You can read through it if you like, but I think it's better just to work some problems. So if we look at this one, we know that the square root of 25 is 5, right? Okay, let's write it out like this. The square root of -1 times 25. That's the same thing as this one, right? Okay, split it into two pieces. What's the square root of -1? It's right there. The square root of -1 is I, and the square root of 25 is 5. But normally you wouldn't write it this way. You would write it as 5I. Usually if you have a radical, so if you still have a square root in your answer, you would put the I right in front of it. But if you just have a whole number like this 5, you put the I after it. So the square root of -25 is actually 5I. Well, let's think about that. Can you square 5I to get 25? That's what that means. If you say that the square root of -25 is 5I, that means you can square this to get -25. Well, let's see. If you square this, you're going to get 25I squared. Well, what in the world is I squared? Well, what's I? I is the square root of -1, right? So if we have 25 times the square root of -1 squared, well, the square and the square root cancel each other out. So you have 25 times -1, which is -25. So that does check out. Okay, so let's try this next one. I'm not sure if you remember from the previous video, but we talked about the prison method. Hopefully you're okay with that. So what we want to do is write the prime factorization of -12. Well, just to start, I want to get that negative out of there. So I'm going to have a -1 times 12. Okay, so let's just keep this little guy hanging out and work on the 12. This will be 2 times 6, 2 times 2 times 3. So if we take the square root of this, the 2's get to escape, but the 3 has to stay inside. So this is what we have if we write it all out. -1 times 2, oops, the 1 didn't take, times 2 times 3. Now the 2's get to escape. Now the only one that's special, that doesn't have to have a partner to escape, is this -1. Because what is the square root of -1? It's I, right? So this becomes an I. This puts a 2 on the outside, and the 3 stays inside. So you're going to have a 2 on the outside, an I on the outside, and a 3 on the inside. And this will be your final answer. Let's talk about I just a little bit. Now, if we already said, rather, that the square root of -1 is equal to I, right? Okay, so we also already said that if you have I squared, I should have written that the other way, but that's alright. If we have I squared, what do we get? This is going to be, do you remember? The square root of -1 all squared is -1, right? Okay, so what if we have I cubed? What's that going to be? Isn't I cubed the same thing as I times I squared? It is, right? So then we have, pardon me, so now we have I, which is just I, and I squared, which is negative 1. I times negative 1 will give us a negative I. So what we have is I cubed is the same thing as a negative I. Whew, okay, stay with me. How about I to the 4th? Isn't that the same thing as I squared times I squared? If you get stuck on this, pause and think about it for just a minute. I squared times I squared is I to the 4th, but what's I squared? I squared is negative 1, right? So we really have negative 1 times negative 1, which is 1. So I to the 4th is really the same thing as 1. It's crazy, right? Let's keep going. How about I to the 5th? I to the 5th, can I say that that's I to the 4th times I? But what's I to the 4th? I to the 4th is 1. So 1 times I is just I. Well, wait, I to the 5th is the same thing as just plain old I. Okay, keep going. Let's see what's going on here. I to the 6th. Can I say that's I to the 4th times I squared? What's I to the 4th again? I to the 4th is 1. And what's I squared? It is negative 1. What's 1 times negative 1? It's negative 1. So I to the 6th is the same thing as negative 1. I'm going to do 2 more. How about I to the 7th? Can I say this is I to the 4th times I cubed? What's I to the 4th again? 1. What's I cubed? Negative I. What's 1 times negative I? Last one. I to the 8th. Can I say that's I to the 4th times I to the 4th? Well, what's I to the 4th? 1. So we have 1 times 1, which is 1. Do you see any kind of pattern here? I, negative 1, negative I, 1. I, negative 1, negative I, 1. I, negative 1, negative I, 1. Isn't that interesting? This pattern will continue on and on and on and on forever and ever. So as long as you keep increasing these exponents by 1 each time, then this pattern will continue. So I guess what I'm trying to say is, if you have something like I to the 21st power, and you want to simplify that, what you should do is figure out how many I to the 4ths there are in I to the 21st power, because I to the 4th is equal to 1. So if you get rid of all those I to the 4ths, then you've pretty much simplified your answer. Well, let's see. How many 4s are in 21? That means 4 times what is 21? Well, you can't get exactly 21, right? You have 4 times 5 is 20, but you need 1 more. Okay, so it looks something like this. I to the 4th to the 5th. Isn't that I to the 20th? But we need 1 more I, right? So I to the 4th to the 5th is I to the 20th times I is I to the 21st. But what is I to the 4th? I to the 4th is 1. What's I to the 5th? Oh, sorry. What's 1 to the 5th? 1 times 1 times 1 times 1 times 1 is just 1. And what's 1 times I? It's just I. So if you wanted to simplify I to the 21st power, you would simply get I. this is just a nice little pattern you can follow. Anytime you want to simplify I to some large exponent, see how many I to the fourth there are, and you can pretty much just throw them all away, because it's always going to be 1 to some power, which is just 1. So whatever is left over is going to be your answer. Okay, so now whenever you are adding, subtracting, multiplying complex numbers, well, let's just go with addition. If you're adding complex numbers, you really just want to combine the like terms. You want to combine the real parts, you want to combine the imaginary parts, and you always want to write it in this form, a plus bi, so that your real part is first and your imaginary part is second. Okay, so look at a. 5 plus 6i plus negative 7 plus 3i. Well, if you add the real parts, 5 plus negative 7, you get negative 2. 6i plus 3i will be 9i. That's all you have to do. Okay, so how about b then? For b, you're subtracting, so you need to distribute that negative first. So you're going to get a negative 3 plus 3i. That's your first complex number. Then you have a negative times a negative. That's going to be a positive 5. And then you have a negative times a positive, which is a negative. So it looks something like that. Combine the real parts. Negative 3 plus 5 is 2. And then you have 3i minus 3i. Well, that's just 0. So b simplifies to a real number, and that real number is 2. Okay, so how about c? This time we're multiplying. We multiply this just like we do all the other multiplying binomials. You distribute everything in the first parentheses to everything in the second one. 6 times negative 5 is negative 30. 6 times 4i is positive 24i. 3i times negative 5 is negative 15i. And 3i times 4i, be careful here, that's a positive 12i squared. Let's combine like terms. That would be these two. So we have negative 30. 24 minus 15 is what? 9. And then, what is I squared again? Do you remember from the previous page? I squared is really a negative 1. Okay, simplify this a little bit more. Negative 30 plus 9i, and then 12 times negative 1 is negative 12. Well, now these are like terms. Negative 30 and negative 12 is a negative 42 plus 9i. Remember, always write your real part first and your imaginary part second. Okay, let me see if I can squeeze d in over here on this side. We have 7 minus 2i all squared. So 7 minus 2i times 7 minus 2i. Hopefully you can still see that. So we're going to multiply these two. That's 49 minus 14i minus 14i plus 4i squared. Combine like terms. So 49 minus 28i plus 4 times negative 1. Excuse me. So that's 49 minus 28i minus 4. Combine your like terms again. 49 minus 4 is 45 minus 28i.